This is Ulrike Ulich, that's the cat. And Mallory Noodle, that's the badger. I think it's a badger. Now, Ulrike is co-author of the illustrator and of the book, of the comic book. And Mallory Noodle is a member of the Center for Democracy and Technology in Washington, D.C. And they're eager to go ahead. Girls, ladies, this is your stage.
Thank you very much. Hi. We'll be reading today from How the Internet Really Works, an illustrated guide to protocols, privacy, censorship, and governance.
It's a book project by Article 19. It's been published by No Starch Press, and it's going to be out on the 1st of December this year. And you can go for news and more information on the website catnip.article19.org.
So for those who don't know it, Article 19 is an international non-profit organization that seeks to promote, develop, and protect freedom of expression, including access to information. They are headquartered in London, but they also have offices in Bangladesh, Brazil, Kenya, Mexico, Senegal, Tunisia, Myanmar, and the USA. Article 19 aims at bridging the knowledge gap about internet infrastructure and why it matters for people. And we have been writing together this book with some other people. And yeah. So I'm Ulrike Ulich. I'm a front-end web developer and a Debian developer. I normally work with projects of the Internet Freedom Community and other non-profit organizations at the intersection of technology, arts, and human rights. And I co-authored and illustrated this book.
And I'm Mallory Noodle. I'm the Chief Technology Officer at the Center for Democracy and Technology. I'm also a co-chair of the Human Rights and Protocol Considerations Research Group of the Internet Research Task Force, and I'm a chairing advisor to the Freedom Online Coalition. With Ulrike, I co-authored the book. And I'm on Twitter at Mallory Noodle, and although it's Halloween and I'm dressed up as myself, Mallory, I'm going to wear my mask, but I don't mind my information being shared online. Thanks.
Thank you. So this is Catnip, or me. Today I'm disguised as Catnip, and Mallory is disguised as Mallory. Catnip and Mallory are basically the main characters of the book. And yeah.
So we're reading from chapter 6 of our book, What Can Interfere with Information Traveling Across the Internet?
And we're also going to be reading from chapter 7, How Can Information Travel Anonymously Over the Internet?
And in the book, the chapters all look like this, because it's a printed book.
Exactly, but for this talk, we've created slides that are more easily followable.
So before talking about censorship and circumvention, let's quickly review the way our data travels.
Data travels in pieces called packets. Each packet has an address tag or packet header that indicates its source and destination address.
Now, there are no direct connections on the internet. Packets travel through intermediary networks and routers that read the packet header to route the packets to their destination. On the image we see on the left, IP addresses on a packet header. This address is using the IPv6 format. And then on the right, we can see a path that the packet takes through intermediate routers to reach a destination server.
By reading the packet tag, these intermediary networks know where they received the packet from and where they're sending it to.
And all of these intermediaries can copy, store, or even alter packets.
Remember that networks can deliver packets as long as the packets have correct packet headers, regardless of the packet's contents. The network itself is content agnostic, It doesn't care about content as long as the packets are routable. This is what we call network neutrality.
And so as far as censorship goes, sometimes states, institutions, parents, or other authorities want to prevent us from accessing certain content on the internet. Censorship methods include blocking, filtering, and throttling.
Blocking renders a website or service inaccessible for a specific set of users and is often put in place with the cooperation of local internet service providers who prevent their end users from being able to make a connection to the website or service.
But filtering is a more general approach to restricting content that seeks to prevent access based on defined characteristics about the content being accessed, such as the use of particular words or image content.
Throttling, also known as degraded or differential service, is used to make access to some services or websites very difficult, slow, or practically impossible for some users.
Those operating the routers, the servers, or the network equipment can filter traffic or block access at the source, during packet delivery, and at the destination.
The reasons for censorship may stem from differing views on morality, free speech, security, religion, politics, or economics.
At the national level, internet service providers can be forced to apply blocking and filtering to all traffic entering or exiting the country.
A regional control of content could rely on the cooperation of several network nodes and can be enacted through autonomous systems.
Even institutions such as libraries, universities, workplaces, or internet cafes can also put in place blocking and filtering controls on content.
There are many techniques that can occur simultaneously to block and filter content.
Here, authorities could block packets based on their source and destination IP addresses. This IP blocking technique can block whole ranges of IP addresses and cut off entire regions. Content filtering?
Whoever controls the router can read the traffic passing through the router. They can read packet headers that include information about the websites we're trying to visit. If the connection isn't encrypted, they can even read the content of websites we visit. This allows public spaces, parents, and routers at the level of the internet service provider to use a technique called content filtering, which filters all pages that contain certain words.
Those pages might be rude words, political parties, sexual preferences, whatever you can think of. And similar to content filtering, URL filtering scans URLs for specified keywords and blocks them.
In this image, we can see a router and a smartphone not having access to the fictitious domain name forbiddenname.net.
And there's also DNS blocking.
Yeah, DNS blocking prevents DNS from resolving specified domain names. Internet service providers implement DNS blocks in the DNS resolvers they control. If a DNS block is in place, when you type a website's address to access it, the internet service provider's DNS resolver either pretends that it can't find the server, or it returns a different IP address, such as one that hosts a warning message.
So when Catnip's browser asks the local or home router, what's the IP address of en.wikipedia.org, and DNS blocking is in place, Catnip's browser will get the information that the address does not exist.
DNS blocking affects all protocols that rely on DNS. So that would be HTTP, HTTPS, FTP, POP, or SSH.
State governments very commonly force ISPs to implement DNS block lists to apply their legal and judicial decisions.
There are many examples of DNS blocks. China, for example, blocks websites such as https://torproject.org. Europe blocked the Pirate Bay in 2017. Germany's federal department for media harmful to young persons has blocked a list of 3,000 domain names. At the request of subscribers, UK internet service providers are required by law to prevent persons under age 18 from accessing hundreds of thousands of sites.
So packet filters.
To read packet headers, routers or servers implement packet filters, which search for protocol non-compliance, viruses, spam, or intrusions in those packets, and block outgoing or incoming packets accordingly.
The filter decides if a packet may pass, if the router needs to route the packet to a different destination, or if the router should silently drop the packet.
Packet filters can also protect networks from attacks by filtering out packets that are aimed to attack servers or routers.
So there's deep packet inspection as well. Deep packet inspection, or DPI, is similar to packet filtering, but instead of simply looking at packet headers, it also reads the data within the packet.
DPI is data processing software that can be used for seeing inside packets to identify, monitor, and troubleshoot network abnormalities. But routers and servers can also use it for data mining, eavesdropping, and internet censorship.
DPI can redirect, tag, block, rate limit, and report, or it can silently drop packets and mark them as suspicious.
In order to inspect packets as they go through a key point in the network, DPI covertly and silently copies packets and analyzes only the copies.
And then there are network shutdowns.
So how are packets routed to Egypt? I can't find it on the map.
Well, I deleted Egypt from the map.
States can easily shut down an entire network by manipulating the Border Gateway Protocol, BGP, the protocol that maps the internet. As we've seen in chapter 4 in the book, which we don't have here, BGP routing is simple and powerful, yet easy to get wrong. Operators of BGP routers or autonomous systems can publish wrong network routes or unpublished network routes to manipulate BGP in order to cut off entire parts of the internet.
We've all heard of the Great Firewall of China. China has a largely state-controlled internet. China limits traffic to some foreign tools and services and forces foreign companies to adjust to national rules and regulations. This set of filters and blocks is known as the Great Firewall of China. It combines many blocking techniques and man-in-the-middle attacks and is therefore very effective.
Content and search removals are another technique.
Censorship techniques can be enacted at the content source, not just over the network. Publishers, authors, and service providers have to comply with legitimate requests or applicable laws to take down, unpublish, unlist, or otherwise hide content when required by law or government requests.
Under the European privacy law, web publishers must also allow individuals to exclude themselves from search results.
So when publishers censor content in these ways, they can pretend that they can't find the content, or for more transparency, can tell the user that the content exists, but that it's blocked. For example, by using the HTTP error status code 451.
The status code 451 is a reference to the Ray Bradbury novel Fahrenheit 451 and is used when content cannot be served for legal reasons.
So now we should talk about censorship circumvention.
So there are many good reasons why internet users might want to circumvent censorship, or why they would want to protect their personal data, privacy, anonymity, or pseudonymity online.
We're going to focus on 3 different methods.
DNS proxying.
To counter DNS blocking, you can use a DNS server that you trust instead of the one automatically provided by your internet service provider.
This was the scenario that we explained earlier. Catnip's browser received the information that an address that Catnip was looking for does not exist.
And by using a DNS proxy, this allows Catnip to bypass the DNS filtering or blocking that may be put in place at that level of a local or national ISP.
The trusted and uncensored DNS server will send back the IP address for a given domain name.
There are also virtual private networks, or VPNs.
To counter surveillance or censorship at your workplace or university, you can connect to a virtual private network, or a VPN, or to a proxy, which would conceal your network traffic and make and receive DNS requests on your behalf.
The VPN provider knows who you are, so a VPN doesn't provide total anonymity.
The VPN provider itself or a strong external adversary can still link your incoming and outgoing traffic to identify you. So make sure you trust your VPN.
In short, a VPN simply shifts the burden of protecting your identifying information from you to the VPN provider.
Tor.
You've probably heard of Tor. To circumvent censorship, we can also use the Tor network to hide our source and destination addresses to anonymize internet traffic. Tor is an acronym derived from the original software project name, the Onion Router. Tor is made up of volunteers who route peer user traffic, creating anonymity through cooperative obfuscation, as Brunton and Nissenbaum call it.
In this talk, we don't explain how Tor works because that would be a bit too long, but it's explained in the book. But here's how to use Tor.
You can access Tor in 2 ways. Either you can manually configure a device or router to send and receive traffic through the Tor network, or you can use several different software applications.
So there's the Tor browser, which is basically the same as Firefox, but routing all traffic through the Tor network. The Tor browser prevents others from tracking you as you browse the web or the dark web.
And then there's Tor browser and Orbot, which are just like the Tor browser, but you can use them on an Android smartphone.
You might have heard of Tails. Tails is a live operating system that makes all network traffic automatically go through the Tor network.
And lastly, there's Onion Share, and this lets you share files anonymously.
Thank you. We were super fast. That's the cover of our book. You can read more about it at catnip.article19.org, and we can have a little chat now if you are up for that.
For sure.
I think our angel froze.
Mm-hmm.
Still frozen angel? We can't really ping the frozen angel, I think.
Well, I would just say I'll take the time to talk about how much fun it's been to work on this project with you, Ulrika. You're so creative and delightful. which is good because we've been doing it for a long time. This book has been in the works for some years now, but it's been great.
Thank you very much. Yeah, I enjoyed it very much too. We've been working on this for 2.5 years, something like that.
Yeah.
And because of the Corona situation, the actual publication has been delayed some months.
Yes.
But we are very much looking forward to holding it on our hands.
In December, and it can be pre-ordered. But yeah, it was supposed to come out in April, and but it's okay because it's pretty timeless. We tried to focus on topics that would be applicable for many years to come. And I think one of the things that might have taken us a while, well, there were beautiful illustrations that needed to be perfected, but also we wanted to focus on making it really accessible and understandable, but also, you know, technically rigorous so that people could really understand how the internet works by the end.
Yeah, we can say some more things about the book maybe. So basically the idea of the book is really to start from scratch, like how does the internet really work? What happens when I connect to a network? What information is exchanged there? How does this information really travel over the internet? And basically you start reading and you will get more and more foundational knowledge, which then the chapters later will build upon. And yeah, we start with quite technical terms, protocols, packets, before we get to what's anonymity, what's pseudonymity, how does the Tor network work, how does encryption work, and in the end, we talk also about algorithms. What are the issues with algorithms right now? I mean, there were several talks here at PrivacyWeek about it that were quite detailed. And then we finished the book explaining really what are the different layers of the internet, how do they interact with each other, how are they governed, and how can we all participate in this internet governance and not leave it to companies to shape how the internet works. Our angel has been unfrozen now.
Hi, yeah, back.
We were super fast.
Yeah, you were too fast. We have actually, we're now still looking for questions from the internet. Yeah, we can chat a little bit. Is there a German version planned?
We would like to translate it, actually. If you know any editors who might be interested, they can contact No Starch Press. That would be the easiest way to do it. And yeah, we've been asked to translate it into several languages and have some contacts for translating it to Arabic, for example.
Icelandic.
But we don't know yet. But we would like to translate it, yes. And possibly even amend the book at some point.
Okay. How did you get this idea? Who had the idea in the first place? Who was it?
It wasn't us, actually. It was a former colleague of Mallory, Niels ten Over, working at Article 19 back then. And his idea was, let's make 5 posters about the internet. But as I started working on this assignment, I noticed that I can't explain the internet in 5 posters. And then we decided to make a book. And then Mallory came into the project and took over, found an editor, and here we are now.
I think it's really useful for, there are a lot of people who work on the internet on various parts of it. Maybe they're software developers, but maybe they're also more like policy people, or they're thinking about hard problems, and they maybe don't have the full picture of how the internet works. Because it's such a decentralized system, that requires so many different things to interoperate and continue running, that a lot of us just have one particular piece of the internet that we understand really well, but we don't get the whole thing. And in my work, as an advocate or a public interest technologist, I am often working with people who know a lot about the internet, but they maybe don't know how it works technically. And I think this book could be really useful because sometimes the ways in which it works technically can have an impact on other things like policy making and decision making, or the ways in which we hold companies or governments more accountable for the things that we'd rather see on the internet, the way we'd like it to work. So this is like the foundation that people need, I think, to be able to engage more deeply with these important questions.
There's a question I'd like to ask you, Mallory, as you being on the connection between technology and the public. We've had this argument going on here that one of our major problems is that people don't understand what we're talking about. When we talk about data security, people give us big stares and say, yeah, it's on my hard drive, isn't it? I can access it. Where's your problem? And before we start trying convincing the society we should adapt our society to the digitalization of this world, is the book the first step, or one of the first steps? I mean, it's much more than the internet, but the internet is a good starting point.
And I think Ulrika mentioned too that we do talk about algorithms, and we talk about the role of companies and other actors in making and operating and changing the internet. So it goes a bit beyond just the internet. And you're right, I think it's a good starting point to just try to understand a little bit about how it works, because there's a big difference between something being on your hard drive, and if that hard drive is connected to the internet, it's very likely that it's also being sent out and then it's on somebody else's hard drive. You don't know who they are or where it is, but that matters a lot, I'm sure, to people.
Yeah, we have this thing that we call chaos macht Schule. Chaos goes to school or makes school, but it's a wordplay that doesn't work in English. And we go into schools, into classes, anything from the age of 8, basically, until they go to college, and even in colleges. And we try to, first of all, answers. People ask me, "Are you a hacker?" And I say, "No, I'm not a hacker. But in a way I am, of course." But we explain what a hacker is supposed to be. And basically we try to explain, because they all have handies, they all have mobiles, they're all in the internet, they all use it, right? And I found that going in there and just talking about dangerous everything is and how bad and how it's full of traps is a bad thing. People like amenities, people like convenience. I mean, I think it's great what Google does if it weren't stealing all my data. I love Google. I think it's a great thing, right? I can connect anywhere, everything. But it's, you know what I mean. And we have not yet found the real way to open up people's eyes to what exactly is happening and why is it going the wrong way.
That's right. I think there's like I was saying before, most people know a lot about the internet. They know how they use it, right? But that doesn't mean they know how it works. And I think showing people actually how it works can give them the ideas. They'll start to understand then, oh, wow, right. Like there's a lot of my data that I'm sending over the wire and I don't know where it ends up, and that'll change.
Okay.
Yeah.
We finally got this question in by the internet I was waiting for. Yeah, what's up with the masks? Some sort of privacy shielding?
Yes, absolutely. For me at least, it was really cool that I could wear a mask during this talk because I have successfully avoided uploading my photo to the internet in the past 20 years. And I want to keep it that way. But we also thought tomorrow is Halloween, and like that you can actually see the characters of the book. When people explain cryptography, they generally explain it with these figures: Alice sending a message to Bob, being listened to by Bob's ex-wife, Eve, the eavesdropper, or being attacked by Mallory, the malicious actor. This is are some of the figures that are used to explain message exchanges and encryption. And we have used some of these figures in the book. There's Alice, for example, but Alice never talks to Bob. She only talks to Catnip, to me, to the cat. And there's actually Mallory, the malicious actor that consciously and actively tries to attack conversations. Yeah, so this is where the masks come from. So you will find these figures in the book.
And this is why I said I'm going as myself, because I'm Mallory, even though I am not a badger and I don't actually have malicious intent or am on path attacking your internet connection. It's just that's my name.
Well, I'm not only a member at the Chaos Computer Club, I'm also a member at the Electronic Frontier Foundation, and their little protector is a badger, and it sits right here in my browser. And so badgers are good and bad. Actually, I have a badger in my garden, to be quite honest, but he doesn't do anything for my browsing experience, I must say. He just makes big holes in my garden.
Yeah, Mallory is inspired by a badger and a raccoon somehow. And even though people consider raccoons to be a nuisance, I like them a lot.
No, raccoons are beautiful. I love them. Of course, they're a nuisance. I mean, my kids are a nuisance, but I still love them. So are my cats, by the way.
Does this answer the question? I hope so.
Yeah, does that answer the question? Let's see if we have another question. Do we have another question out there? Control, Regie? No, it doesn't look like it.
Okay.
Yeah. Well, I'm afraid we're sort of beg pardon. Yeah. Hacktivism mit German version. I don't really know. We're out of content, aren't we? Sort of at the moment.
Somehow.
Somehow.
Something I can still say is that if you go on the website, you can also download the chapter that explains how Tor works. We released in 2018 like a big poster, and you can download that version as a PDF from the website. But it has changed a lot in the book, so it's not exactly the same anymore. Nevertheless, go ahead, download, and give feedback if you're interested.
What's the website?
That's https://catnip.article19.org. And yeah, you can also give feedback and get in contact with us through a contact form there, or by writing it to catnip@article19.org. That should arrive in our mailboxes.
Is that article fully spelled, not abbreviated?
Yes, correct.
Oh, and in German we call it Regie, and in English I think it's called Control. They have just posted here, they definitely want the German version of the book.
Yay!
And I know for Chaos macht Schule, I want a version of that book as well.
That would
and
be great.
I want to find a sponsor so I could give it away to schools.
That would be great.
That would be great. Okay, I think we're going to call this a day. Thank you very much for joining us, Mallory, from over the pond.
Yeah.
Thank you very much for joining us, Ulrike, from in Germany, wherever you are. I hope my dropouts didn't bother too much. As I said, I'm on LTE and Friday evening, and it's 6 o'clock, and everybody's coming home, and let's call Daddy, and okay, out we go. Oh, there's a question.
Oh.
Wow. Can the book be reused, remixed? Is there a license? Do you plan making a version on how the web works?
Good questions.
That's a good question. I have no real answer to this right now. Do you have one, Mallory?
I'm pretty sure it's the licensing's open. We can make that more explicit. At some point, we can maybe release the illustrations and the text somehow, either on GitHub or on the website that Ulrike set up. But yeah, because Article 19 is a nonprofit organization, and I know that they tend to publish with open.
And that would be Creative Commons.
Yeah, that's right. And then, yeah, I was actually going to ask if we could ask the audience, like, for ideas on another project. I think how the web works would be really interesting, although it's changing a lot. So it might not be a book that could last very long. Or maybe how mobile networks work. Because that's
actually, you could finally explain the difference between the internet and the web.
Yeah, there is a big difference.
I know there is, but most people don't. I have another question here.
Okay.
Rhonda asks you, I know this might be quite of an inside question, but when you mentioned raccoons, is that a reference to a certain conference 5 years ago we both attended, Ulrike?
Mm-hmm. No, not at all. No, not at all.
Rhonda, you can see her giggling.
Very cute. Hi,
Okay.
Rhonda.
Oh, and by the way, you're just getting kudos for using IPv6.
Yay.
Okay, come on, people. Let's have some more questions. No, come on. We got a quarter of an hour. No, 10 minutes. Yeah. Okay, no, let's not milk this cow further than it is milk in the other. Sorry.
Thank you for having us.
Yeah, thanks a lot.
Thank you for joining us and making this happy and making our good experience. And just let me finish off the talk with the things that we usually say when we go off the air. Thanks everybody for attending here. Thank you all the people that are out there and helping us. Thank you for all the participants that come and join us and not getting any fees. Or everybody's working for free to make this thing happen here and to make it happen for free. And the fact that it's for free and you don't have to pay any admission fee is due to our sponsors. So let me mention here the Austrian Chamber of Labor, Vienna section, who is supporting us with money, and the next there, who's a provider, an internet data center, who's given us a large portion of their data center, so we have stable connections for you. If you still want to join us and become an angel, because this angel means angel in German, and yes, angels are relevant because we call those people that work for us and help us and work together with us to make this happen, we call them angels. Otherwise, the next talk is in 10 minutes, something like that, quarter of an hour. And it's global problems need global solutions, or in German, globale Probleme brauchen globale Lösungen. No, sorry, I'm talking nonsense. I'm actually talking nonsense. The next talk is Privatheit und Selbstbestimmung, Autonomie und Öffentlichkeit at 1800 here on this channel. The talk I said before is the talk at 1900. I can't read anymore. I'm getting old. I am old. Never mind. Thank you for joining us. Come back here in a quarter of an hour, and the next talk will be around. Thank you, Ulrike. Thank you, Mallory. Bye-bye, everybody, and let's go up here.
Thank you for joining. Bye.